Hello everyone, this is the help video for spiral review number 2. And as always, these spiral reviews are intended to help you to review items that you learned in a previous unit. So this specific spiral review is going over topics that we reviewed in unit 2. As always, you can use a calculator on each question. So first, let's go over laws of exponents, which was our first lesson in unit 2. And this equation or expression, excuse me, involves two different types of laws of exponents. So there is a little graphic up in the corner there, as you can see, and we have two different laws of exponents that we are going to use to solve this expression or to simplify. The first one we're going to use is the power of a power rule. Power of a power rule states that if you have an exponent that's being raised to another exponent, you can multiply those exponents. So I have a base of 5, and then I do have double exponents here. I have 3 to the power of 5. So because I have an exponent raised to another exponent, I can rewrite this as 3 times 5, or 5 to the power of 15. So now I've simplified this section, and I'm going to bring down what is remaining of my expression. What I have left is 5 to the power of 10. So now I have the same base, and these bases are being multiplied. Product of power rule states that if you have the same base being multiplied, you can add the exponents. So I can rewrite this as 5 to the power of 15 plus 10, which is the same as 5 to the power of 25. So this question 1 was reviewing two different laws of exponents rule. We reviewed power of a power and product of powers, and these steps will help you with question number 1 on your spiral review number 2. The next question that we have is adding expressions. When we add expressions, we can drop those parentheses and combine like terms. So I'm going to rewrite this without the parentheses, again, because there is that plus sign in the middle of these two expressions. I can simply drop the parentheses and combine. Now, what's important here, of course, is highlighting or in some way identifying our like terms. And again, like terms are anything that have that same variable and exponent combination. So in this situation, we have these two terms that both have the value of x. So I'm going to rewrite this as 1.4x minus 0.6x. I'm gathering together the things that have like terms. And then I have -10 and -14. So again, I can write those -10, -14. So now that I've color-coded my like terms, I can go ahead and simplify to solve. So for my first one, I have 1.4x minus 0.6x. That's equivalent to 0.8x. And then I have -10 minus 14. That's a -24. So this would be my final answer. There's nothing else I can do with this expression because they are not like terms. So one term has an x, one term does not. So there's nothing further I can do. This would be my final answer. So these notes will help you with question 2 on your spiral review number 2. And here's number 3. Well, again, we have adding and subtracting expressions. In this situation, we are subtracting expressions. So when we subtract expressions, excuse me, there is one extra step. This subtraction sign needs to be distributed to the terms in that second set of parentheses. So I'm going to rewrite all of these terms, but this time I'm going to rewrite this with the second set of parentheses gone and that negative sign being distributed. So when I distribute a negative to -5, that's going to give us a +5. And when I distribute negative to positive 1 over 10, that's going to give me a negative 1 over 10. Again, I can go ahead and color code these so I can combine like terms. So I have my variables and I have my constants that have no variables, and I can go ahead and rewrite. So I have 3x plus 5x. I don't know why my pen got so skinny. There we go, that's a little better. 3x plus 5x. And that simplifies to 8x. Then I do have these fractions over here. I have 1 over 5 minus 1 over 10. So because I have unlike denominators, I cannot just combine like I would normally want to. I do need to find like denominators in order to combine these. So 1 over 5 minus 1 over 10, I can rewrite 1 over 5 as 2 over 10. Those are equivalent. So I have 2 over 10 minus 1 over 10, and that leaves me with a solution of 1 over 10. So this would be my final answer here, 8x plus 1 over 10. Again, from the beginning, distributing that negative sign because we are subtracting expressions to both the terms inside the second set of parentheses, identifying our like terms, and combining those like terms. So these notes will help you with question number 3 on your spiral review number 2. And here's number 4. So question number 4, we are using order of operations in order to figure out the best order in which to solve. So I'm going to move my little camera down here so you can see this image in the top corner. Often we use order of operations using PEMDAS. That's been a common acronym that we use, but this state of Florida is shifting to more of a GEMS model. So let's just briefly review what GEM means. It's the same concept as PEMDAS, very similar. However, it is a little bit more streamlined to eliminate some confusion. So standing for G, we have grouping symbols. So previously we had parentheses. Now we have G for grouping symbols, and this would include any parentheses, brackets, absolute value bars. Any of that would fit into that idea of G grouping symbols. E is the same. E is for exponents. Nothing's changed there. M is for multiply and divide, and you'll notice how now multiply and divide is one step. So multiplication and division moves from left to right. So one is not more important, or one does not precede the other. They are the exact same step, and you complete that from left to right. And finally, we have S, which is subtract and add. Again, this is the same step. So one is not more important than the other. You complete them in the same step from left to right. So we can go ahead and solve this one with the information that we have with GEMS. So first, of course, we're going to look for any grouping symbols. We do have these parentheses here, which means we're going to focus our efforts inside the parentheses first. Inside the parentheses, we have 3.11 plus 1.12 divided by 2. Here's where the rest of our GEMS is going to come into play. We have the operation addition and division. Division comes before addition. So we need to go ahead and solve that division problem first before we solve the addition problem. So I have 1.12 divided by 2, and this leaves me with, I'm going to rewrite everything else just so it's all here. 1.12 divided by 2 is 0.56. So now I've simplified this portion, and I can move on to the next part of my my expression here. I still have those grouping symbols, those parentheses, so I'm still going to solve what is inside those parentheses. I have 3.11 plus that 0.56, and this simplifies to 3.67. So now that I figured out everything inside the parentheses, Now I can focus on the last two operations that I have. So I have 30 minus 5 times 3.67. Again, we look to our gems to see what takes priority. Since we have a subtraction problem and a multiplication problem, the multiplication problem is going to take precedence. So 3.67 times 5 gives us the value of 18.35. And now we are down to just one step. We have 18.35. That's being subtracted from 30. When we subtract that, we get 11.65. So again, order of operations, nothing has changed in terms of the gist of order of operations. Now we are transferring from using PEMDAS to something like GEMS, just to eliminate that confusion. Again, any grouping symbols, any exponents, multiplication and division, and then addition, subtraction is your fourth step. So these steps can help you with question number 4 on your spiral review. And the last question that we're going to go over here is for equivalent expressions. And in this specific equivalent expression, we are going over distribution. So whenever you have something, just like we reviewed in question 3 with that negative sign, anything outside of the parentheses needs to be distributed in via multiplication. So we can write out two different problems here. This is like saying 1/6 times 12x and 1/6 times -36. So we have two different multiplication problems here that we can solve. 1/6 times 12x is the same thing as saying like 12x divided by 6. So this would simplify to 2x. Then we have 1/6 times -36. This is like saying -36 divided by 6, which is -6. So this would be our final answer here. Again, anything outside of the parentheses would multiply into the two terms inside the parentheses. Don't forget that symbol or that sign in front of the 36, that is a -36. And the final answer is 2x minus 6. So at this time, we have now reviewed all 5 questions in that spiral review. As a reminder, the numbers in my examples are different, but you can use the same steps. So there are also notes available if you need additional assistance when completing this, and you can also reach out to any teacher if you have any questions. Thank you for watching.